So hello to everybody. We are waiting for the last guys who are also connecting. Yes, so I see almost everybody's here, or still some guys are missing. And the agenda for today will keep English, but then in the next lectures we'll shift into Polish. What I would like to do today is just I would like you now to hear in a moment two lectures which are have been recorded previously, because I'm not sure about the connection in real time, and then we'll meet for the seminary. What I would like today to discuss during these lectures is something that could be called symptom modification. Symptom modification. So basically we discuss something like that, when we are discussing in our third year course the synthesis of carboxylic acid. So basically what we are using is, let's say, the esters of carboxylic acids, which have here this acidic hydrogen. So these are simply the CH acid, so-called CH acid, and by the removal of this hydrogen we are obtaining here carboanion. However, what about such a functional group interconversion in the language of retrosynthetic analysis, to have, let's say, instead of the acid, instead of the ester, we will have here the free acid, free carboxylic acid, which could also be subjected to such a removal of that hydrogen. And a truth is that contemporary chemistry answers this question positively. So we can use such anols of the carboxylic acid in the synthetic approaches, and even it is better than the esters. This will be discussed in the following lectures. So first is functional group interconversion, and then we can also have such a modification which will call the enhancement of the reactivity. So reactivity enhancement, let's say that we once more will have such a symptom with, so it will be D2, so the 0, 1, 2, yeah, D2 donor 2. However, we could also have a similar symptom, let's say here, as the malonic acid, O, 1, 2, and if minus, so by the removal of this hydrogen we will obtain something like that. So once more D2, a D2 symptom, and we see that such a symptom such a symptom has the reaction equivalent, which will be more active than the original symptom. So we know from third year course that the synthesis from malonates or malonic acid are just the typical way of obtaining carboxylic acids in that kind of synthesis. So simply that symptom is an activated form or of that monocarboxylic acid derivative. And then we can have something like masking group. So for example, we can mask the activity. So a typical reactivity here we have it is the acceptor 1, so acceptor 1 after the removal of that group, so we'll have something like that, and the acceptor 1. But then we can have something one more like functional group interconversion, and the change of reactivity to such a form or such a form basically which have the donor type. So O1, it is a donor 1 type of reactivity. So that's simply masking of that group, because we cannot react that group with nucleophile. So it reacts here very nice, but cannot react with that one. And because we can have here also the reaction coming back to that type of functionality, we have something that blocks that group. So blocking, it is a blocking of the reactivity, or masking or blocking of the reactivity of the carbonyl function. First, a second, it is an example of the so-called Umpolung reactivity change. So we are changing the reactivity from the acceptor type, so from the electrophile to the donor type to the nucleophile. Of course, it is only an example, and I'm discussing that because these 3 lectures that are recorded are showing the examples of that, are discussing the examples of the using of that kind of strategies, and we'll discuss that in details in the next lectures, even more detailed, in a more detailed form. However, today I would like you to go through these exercises, so more or less the examples of the disconnections, using once more this known example of the phenylsulfonyl valeric acid derivative, to be more flexible, to be more experienced with this connection approach. So it is the first thing what we are to do. So first go through this series of the lectures. I'll send you the links in a moment. And second will be the seminary, and I would like to ask you a question if you are ready to discuss, I mean, these examples that you were to go last week. I mean, these examples coming from molecular memory, to rewrite that in the schemes that we are using during these lectures? Are you during this lecture series? I mean, this with two sides of the table of two sides of the paper, of the paper sheet. Are you ready to discuss that? Hello, do you hear me? Can you hear me?
Yes.
So if you are ready, then we can discuss that. So basically we'll meet at 11:30, so just 11:30 to the seminary. If you are ready, then we'll discuss that. If not, so I would like you once more to prepare this for today, later, or for next week. Or alternatively, you can discuss also the projects that we are to prepare for the this series of lectures. I mean the project on the innovation and retrosynthetic analysis or something similar, reframe of that topic. So now I'll send you the links to that lectures, and this can be found simply on that my YouTube channel. So my YouTube channel, yeah, I can just show you on your pulpits, and we have here, can you see that? Can you see my desktop?
Yes, we see you.
Okay, so playlist, and then we have here introduction to organic synthesis, I mean on that playlist. And then and here on that playlist you have a first share, so copy, so it is the first. Second, third, yeah, so it is 1, 2, 3, 4, 5. Let me see if everything has been copied here. So 1, 2, 3, 4, 5. So 5, yes, 5. Now it should be 1, 2, 3, 4, 5, 6, 7. It would be 7 units. So jeszcze raz, proszę Państwa, czyli tam jest 7.